Here we are, part D, F, and H. Nice way to letter these, but nevertheless. Where in the intervals 0 to 8 does F, capital F, achieve its minimum and maximum value? Well, let's think back to when we learned how to find minimums and maximums. Well, we did this back in chapter 4, sections 4.1 to 4.3. We know that capital F is the function we're trying to maximize or minimize. Okay, well, capital F, we can see the graph up there. And what do we know? We know that F prime is equal to 0. So we need to find our endpoints and also our critical points. Well, F prime is equal to 0 when F, because F prime, remember F prime is equal to lowercase f, when F is equal to 0 at x equals, well, if you look at the graph, capital F has a value of 0 at 3, at 5, and at 6.5. Okay, so those are the critical points. At x equals 3, at x equals 5, and at x equals, what did I say, 6.5. So that's when capital F prime is equal to 0. Okay, well, let's do a capital F prime test. Okay, and that's, again, that lowercase f test. I know, it gets confusing. So then we put our 3 here, our 5, our 6.5. Now we have to put our endpoints as well. Okay, capital F prime, which is f, is f positive or negative on this interval? Well, we can clearly see that the graph of lowercase f is above the x-axis from 0 to 3. 3 to 5, it's below the x-axis. 5 to 6.5, it's above, and then 6.5 to 8, it's below. So F prime, capital F prime, is positive, negative, positive, negative. So we know then that capital F is increasing, decreasing, increasing, and decreasing. What I'd really like you to do is I'd like you to make a connection between this sign chart down here and looking at the graph up here. You're accumulating more snow from 0 to 3 hours. You're losing snow. In other words, snow is melting from hours 3 to 5. More snow is falling than melting from 5 to 6.5. And then more snow is melting than falling from 6.5 to 8. Okay? Well, we already know what the values are at all these critical points and then at the end points. We know that capital F of 0 from our chart way up here, so we have our chart, okay, capital F of 0, our minimum, so capital F is at a minimum when x is equal to 0, is equal to 0. Capital F at 3, we said that was 13 halves. Capital F at 5, we said that was 13 halves minus 4, so that's 5 halves. That's a minimum. Okay. And then capital F at 6.5, we said that was 3 plus 1/4, so that's 13 fourths. So 3 and 1/4. And that's a max. That's a max here. And then at 8, we said that capital F of x was equal to 2. Okay? So the snow level is 0 here, that's a minimum. 13 halves, 5 halves, 13 fourths, and 2, at least the snow level compared to what it was at t equals 0. And so it says where in the interval does f achieve its minimum and maximum value. So the biggest max would be the 13 halves. That's 6.5. Okay, that's the biggest. That's the absolute max. So if we want to use the same terminology we've used before, our absolute min though is at 0. At t equals 0. Okay, absolute. Okay. All right. Okay. And then, so what do we have here? We've got, sorry, people moving around here. Minimum and maximum value. Okay. So the maximum value from 0 to 8 is 13 halves. It occurs where in the interval? So at t equals 3, let's see, where can we answer this? So to answer part D, at t equals 3, the maximum value is 13/2 inches. Okay, that's how high the snow level gets. Okay, at t equals 0, that's when the minimum, remember we accumulated more snow in that 8-hour period than we lost, so the minimum is going to occur at the end point, and the minimum is 0. Okay, so there we go, that's part D. Find the concavity of F and any inflection points. This is a cool problem. So the concavity of F would be F double prime, but F double prime is F prime. Okay, and F prime, there's just not a whole lot of room right here. F prime is greater than 0 on the intervals from, okay, so if we look at the graph of lowercase f, f prime is greater than 0 on the interval from 0 to 1, because lowercase f prime is the slope of lowercase f. And lowercase f, you can see the slope is positive from 0 to 1. So on the interval from 0 to 1, okay, and then when does f prime become positive again? Well, on the interval from 4 to 5, from 5 to 6. So we can say from 4 to 5, and from 5 to 6. Okay, and then it's no longer going to be positive there. Okay, so that's where we have f double prime, capital F double prime, equaling or being positive when f prime, lowercase f prime, is positive. Okay, so then that's where capital F is concave up. Okay, so capital F is concave up on these intervals. Okay, capital F is concave up on those intervals. Well, lowercase f, which is equal to capital F, lowercase f prime, which is capital F double prime, is less than 0 on the intervals from, we can see from 2 to 3 and from 3 to 4. So from 2 to 3 and from 3 to 4, the slope of lowercase f is negative. And then also from 6 to 7, the slope of lowercase f is negative, from 6 to 7. Okay. Now, personally, it's hard for me to not see a sign chart. So I'm going to build a sign chart here, way down here at the bottom. And on this sign chart, I'm going to put 0 and all these values where lowercase f prime doesn't exist. Okay. Or lowercase f prime is equal to 0. Okay. So again, this is where f double prime, which is lowercase f prime. Okay, I'm running out of room here. Okay, capital F double prime, which is lowercase f prime, does not exist at x equals 1, 2. It looks like there's a kind of a sharp point right there at 3. Okay? As you can see, the slope is down 3 and over 1, negative 3 and down to negative 4. So there's a sharp point there. And then at 4, and then at 5, more obvious, at 6, and then again at 7. So we have all these critical points. 1, 2, 3, 4, 5, 6, 7, 8 is here. Okay. So this is where, again, capital F double prime does not exist. So these are the potential inflection points. Okay. I know this is a lot here, so it's a good thing it's in a video so you can go back, because you're going to be getting these kinds of problems, typically not to this degree, but you will get problems like this where you're looking at this kind of a problem here, you're looking at the graph, and you're trying to answer the question, when does capital F have inflection points? Okay. And then, so we know that F double prime, capital F double prime, is positive from 0 to 1, positive from 4 to 5, positive from 5 to 6. Okay. It's negative from 2 to 3, negative from 3 to 4, and negative from 6 to 7. Okay, well, what in the world is going on between 1 and 2? Well, that's when f lowercase f prime or f double prime is equal to 0. So it's equal to 0 all here, so we're not going to have any inflection points there. Okay, so we would have inflection points when we change from concave up to concave down, or in other words, when f double prime changes from negative to positive, right there, or from positive to negative, right there. So when x is equal to 4 and when x is equal to 6, we have capital F has an inflection points, at when x is equal to these values. Okay? So that being said, we have one last part, and that would be to sketch a rough graph of f of x. Okay, so we just look at our values of f of x, and we get f of 0 is 0. Okay, f of 0 is 0. And then we have capital F of 1 is 2. Capital F of 2 is 1, 2, 3, 4, 5. And then we have 13 halves, which is 6 1/2. 6 1/2 right there. And then we have 13 halves minus 4 halves is 9 halves. That's 4 1/2. 1, 2, 3, 4 1/2. Okay. And then 6, 1, 2, 3, 4, 5. Oh. 13 halves minus 8 halves, 5 halves is 2 1/2 right there. And then 6 is 3. We accumulated a little bit there. And then 7 is 6 1/2 is 3 plus 1/4. And then back to 3 and then back to 2. Okay? So this is our rough graph of f of x, capital F of x, the values of capital F of x. And, wow, you didn't see a lot of that, did you? My apologies, but nevertheless, I've got my kids here. They're going to hear these videos in a few years. So, I'm going to sign off now, and I hope that helps. We will talk in class, but on the Google form, just indicate which parts of these you're a little bit unsure about, but only after you do a few practice problems, and then we can go from there. But don't worry, we're going to be spending a lot of time on this. I do understand it takes a while to sink in, and but don't worry about it. It will sink in, and you will understand it if you just put the time in. I promise.